exam ready? Achieve top grades. Welcome to Surds Part 2. In this session, we're going to apply surds to fractions, Pythagoras theorem, and ratio. Let's look into more details what's going to happen. In section 1, we are combining fractions with surds. And that means we're going to add and subtract surd fractions using a common denominator and rationalizing. Then we're going to be applying Pythagoras theorem. In this case, we're going to be finding missing sides in right-angled triangles where lengths are given as surds. And thirdly, we're going to be solving ratio problems. So let's move on to the next slide. Time to recap. What we've seen last time was there were 4 rules by which we went through the surds problems. Okay, so the first one is the multiplication of surds. Just as a quick recap, if you haven't seen the first video, so let me go through that again very quickly. So if here you have root 5 multiplied by root 3, you're going to get root 5 times 3. And that ends up with 15 square root. Division of surds. If you have 12 root divided by root of 3, so we can combine these two as a division of 2 surds, so that gives you 12 over 3 under the square root, and that gives me square root of 4 and eventually 2. The third one is the square root of a multiplied by the square root of a, which ends up giving a. So if you take the square root of any number, let's say a square root of 5 multiplied by square root itself, it's identical, so you end up with 5. If you take the square root of 2/3, you multiply this with the square root of 2/3, you'll end up with 2/3. The last one is the combination of surds through addition and subtraction. If you got 4 square root of 7 plus 5 square root of 7, then you get 9 square root of 7. If you want to do the subtraction, in that case, 20 root 6 minus 10 root 6, that will give you 10 root 6. So this is about the rules of surds. And now we're going to move on to section 8, which is about combining fractions with surds. So let us see how that works. Now, the first question is to simplify a fraction plus a whole another surd. Let's see how it goes. Now, before we go tackle this problem, so if we consider a fraction plus a number like this, so one thing we can do is we cross multiply this b with c, so we're going to get a plus b c, and then we divide everything by b. Okay, so that's how we're going to do it. Now, if we have here 3 over root 2 plus root 2, what's going to happen is we're going to multiply this across. We're going to get 3 plus, now if you remember the rule where we said root a times root a is going to be equal to a, so that's the squaring rule if you remember this. So root 2 times root 2 is going to give me 2, and the whole lot will be over root 2. So that gives me 5 over root 2. Now, normally, we don't want the surd to be in the denominator. We want it to be in the numerator. So how are we going to do this? In that case, we are going to multiply this with root 2 over root 2, which is in fact 1. It doesn't change the value, it only changes the form. So in that case, we call that rationalization, and we end up with 5 root 2 over 2, and that's the answer. Now, second question. So this is quite similar to A over B plus C over D. So we're going to use the smiley method. Okay, what is the smiley method? So we're going to cross multiply A and D, cross multiply B and C, and here's the smile, B times D. So let's do that again. So A multiplied by D, so AD, B multiplied by C, so that's going to be BC, and that's over BD. Okay, so let's do that. Over here, we got 1 over root 5 plus 1, and then plus 1 over root 5 minus 1. Okay, we'll put the brackets to, so that we don't get mixed up. So like we said earlier on, we're going to do the cross multiplication, cross multiply and smile. Okay, let's get started. So first cross multiplication, which is root 5 times minus 1 times 1, which is root 5 minus 1. Okay, so that's what it is, plus, and then the second cross multiplication is going to be 1 times root 5 plus 1. And at the bottom, I think you remember, it's called the difference of two squares. That's the rule we're going to apply, because you got a surd and its conjugate. Okay, let's simplify the numerator. So we're going to get root 5 plus root 5, that is 2 root 5. Minus 1 cancels the plus 1. And underneath, as the denominator, we're going to do the difference of two squares, which means square root of 5 squared minus 1 squared. And what does that give us? That gives us 2 root 5 divided by 5 minus 1, which is in fact 4. So that's 2 root 5 over 4, and then we simplify it further, and that gives me half. So root 5 over 2, or half root 5. So that's the answer. Next one. Now we got 2 over root 3 minus 1 over root 12. Okay, now that looks a bit like this type of calculation. So we're going to do our cross multiplication as we did before. So let's multiply these two together. So that's going to be 2 root 12 minus, multiply these, minus root 3. And also we're going to get root 36. Now there are a couple of simplifications we can do, such as square root of 12, which is the same as 4 times 3 under the square root. That one is just going to give me 2, and then we are going to get root 3 as a surd. So why do we have that? It is because over here I'm going to replace this by 2 root 3 minus root 3. Underneath you got square root of 36, which is 6, and that goes as Now over here you got 2 times 2, which is 4, and that is a 1. 4 minus 1 is 3, so 3 root 3 over 6. And that can be further simplified as half of root 3 or root 3 over 2. Okay, here we go. Now, have a close look at what we've done so far, and I'm going to be asking you to do the next one, which is your turn. Okay, after you practice this, I'll show you the answer. You can pause the video here and let's practice. Okay, so you'll see the answer on the next slide. Okay, let's move on now. So if you've tried doing this by yourself, so you should be able to compare your work with mine, and we can move on to section B this time. Okay, we're going to apply Pythagoras theorem with surds. A right angle triangle has sides root 8 and root 28. Let us see what we got in that case. So in order to apply the Pythagoras theorem, let's draw a triangle. So the shortest sides are, okay, we've got a right angle triangle. The shortest sides are A and B, and the longest side is the hypotenuse, which is C. Pythagoras is very easy as ABC. So remember, ABC, A squared plus B squared equals C squared. So C being the hypotenuse. So if we start with this question, a right angle triangle has sides, okay? So we're talking about A and B here. Find the hypotenuse. We're going to try to find C. You can rewrite the equation in that way. C squared equals to A squared plus B squared. Okay, let's do the substitution after writing the formula. So A is square root of 8, which you're going to square. Then you got B, which is square root of 28, again, which you're going to square. Now, squaring a square root cancels that out. So A that ends up with an 8. And here we got square cancel the square root. That's going to be 28. So C squared is equal to 36. And C is the square root of 36, which is going to give me 6. And don't forget to put the units. That will be 6 centimeters, and that's the answer. Next one, you got a right angle triangle that has got a hypotenuse. Okay, so that's our C. One of the sides, let's call that A, and we're looking for B. If you remember, A squared plus B squared equals C squared. Now, because we are looking for B, we make B the subject, and we send A squared onto the right hand side, so we're going to get C squared minus A squared. So you just can go and write this formula straight away. You don't have to show this working out, which I've just explained. So B squared is equal to C squared minus A squared. And let's do the substitution now. This is what examiners look for. They look for structure in your work, and that's what I would emphasize all the way in all the sessions I'm going to do. So C is 6 root 5 that I'm going to square. A is 4 root 5 that I will be squaring as well. So that gives me 36 multiplied by 5, take away 16, multiplied by 5. Now 36 take away 16, that gives me 20. So that's 20 times 5, which is 100. And don't forget, this is B squared. So if B squared equals to 100, therefore B is going to be 10, and the unit again is in centimeters. So that's the answer. Finally, you got a right angle triangle that has got sides. So we're talking about the sides here. So let's call that A, let's call that B. So find the hypotenuse. So we're looking for C. So C squared equals to A squared plus B squared. and a squared. So we're going to be squaring root 12, and then we're going to be squaring 4. So that's going to be 12 plus 16. So c squared is going to be equal to 28, c being the square root of 28, and that is 4 times 7, 4 times 7, which means this one you can get 2, you can extract 2 from that square root, and then you get 7. So c equals to 2 root 7, and again, that's the unit is centimeters. Now we're going to show you the questions on the right hand side, and that's for you to practice on your right hand side. Okay, so I'll leave this with you. Practice and take your time to finish this, and then we're going to compare answers on the next slide. See you on the next slide. Here we go. Okay, you can pause the video here and you can mark your work. Okay, and you can cross check with my answers. Now on to section C this time. So we're going to be writing the ratio in terms of in the simplest form again. So here we go. Square root of 45. We're going to get 45 is 9 times 5. Then you get 4 times 5 for 20, and square root of 9 is 3, root 5. You got here 2, root 5. We cancel out the 5s, and we end up with the ratio of 3 to 2, and that's our answer. A rectangle's length and width. Okay, so length is to width, 5 is to root 5. Now the width is 2 root 5. So we can see a multiplication factor of 2 here. So that means times 2. That gives you 10, just 10. Find the length. Okay, so the length now is 10 centimeters. That's the answer. Finally, you're going to simplify the ratio, and that's going to be 8, 72, 128. 8 is 1 times 8, 2 times 4. Okay, here's a big square number. Okay, and then hopefully we're going to get the same number for all the others. And let's see. So 72, that's 172 to 36. Okay, so 324. Well, 36 is already our biggest square number, and we got 2 here as well. So I think that's where we stop for 72 and 128. So that's going to be 1 and 128, 2 and 64. Okay, and we got 2 here, and you will notice these are square numbers, all of them. Okay, so here we go. So we're going to write the first term. First one is root 8. So root 8 is simply 2 times 4. Then you got 2 times 36. And then you got 2 times 64. So what's going to happen now is we're going to get the surds root 2. And the square root of 4 is going to be 2. Another surd root 2. Square root of 36 is 6. And the last one is going to give me 8 and then root 2. So we can cancel the root 2 all the way, which means divide by root 2. So you can say divide by root 2 all the way. And also, you will notice that these are all even numbers. You can further divide by 2. You're going to get 1, is to 3 is to 4. That's the answer. Okay, so your turn now to work out the next questions, and that is going to be on the right hand side. Here we go. And you can check your answers on the next slide after pausing. Okay, so these are the answers, and check your work and pay attention to details. Okay, so now it's time for us to recap on the 3 skills you've gone through. So first of all, we combine surd fractions using common denominator, and then we rationalize the fractions. Secondly, we applied a squared plus b squared is equal to c squared, which is the Pythagoras theorem for right angle triangles. And finally, we did simplify surd ratios by factoring out the common surd. So hope you enjoyed this video. In the coming session, we're going to be looking at how to apply surds to areas of shape, geometric series, and to trigonometry. Okay, until then, it's goodbye from me. Thank you.